We're going to have to do this very quickly. There's not a lot of time left in class, so I will post the answer key for both of these so that you will be good to go for our quiz that we have on Monday. But really, these are from 1 through 4. These are just old AP questions that I pulled from different AP tests. The periodic trend type questions, they didn't change that much in the curriculum, so I think really that's going to be very similar to what you'll see still on the AP test, on the AP exam. So that's what you'll see on my test too. So for example, one like number 37 here, which is actually number 1, right? But it's number 37 on that particular AP exam. It says the ionization energies from element X are listed in the table above. On the basis of the table, element X is most likely to be. And so we're basically just looking at the data for element X. The first electron that we pull off takes 580 kilojoules per mole. The second one, 1,815 kilojoules per mole. The third one, 2,740. The fourth one, 11,600. And the fifth one, 14,800. Okay? So what you're looking for on a graph like this or a table like this, you're looking for where there's a really big jump in energy, where all of a sudden it's taking a lot more energy to pull the electron off. Where does the big jump really happen on this graph? Yeah, from the third to the fourth, right? Okay, so what that tells us is, now granted, it's going to increase each time because, you know, the more you pull off of there, the higher the ionization energy is going to get, okay? But these first 3, it seems to increase in a relatively normal manner, and then all of a sudden you have this huge jump if you try to take the fourth electron away, okay? So which element would that most likely be on the list that they give you here? It would probably be an element where you can take the first 3 electrons away from it with not too much difficulty, but then when you try to take the fourth one away, it's going to be hard, which would be aluminum, right? Okay, does everybody see that? Aluminum has 3 valence electrons, so you try to take that. And what you can also see here is a pretty decent jump between first and second, which might correspond to, okay, you're taking a p electron from that first electron is a p electron out of the aluminum, and then the second one is going to be the from the s orbital, right? Okay, so that seems to fit the data pretty well that we're looking at here. Okay? Again, a lot of these are just the same types of questions you would see about ionization energy, atomic size, all that stuff. We should be able to answer all those questions now. I don't know that there's anything else here that's weird, honestly, after what we talked about. You got another PES question here, which I think you should be able to answer without any difficulty after what we just did. Another PES question. Modifications to the Bohr model that are required. Okay, we talked about that too. Now this one you actually have to draw your own photoelectron spectrum for aluminum, okay, which includes all the peaks. You should be able to do that as well now. Okay, I want to make sure that you can go backwards and you can actually draw one of these things. Now, you don't have to include the exact ionization energies, okay, because you'd have to go and look those up, and I don't care that you do that. I just want you to be able to give me a good rough sketch of what aluminum's peaks would look like, okay? And then it says to label the peaks with the numbers and letters. I would go through and actually try to do that just to make sure that you know how, because you might find yourself having to do that on a quiz or a test, possibly.
Next week.
Hint, hint. All right. And then there's a couple book problems that are good. I don't know if I've told you this, but the book problems that I typically pick are the ones that have pictures associated with them so that you can get a little more practice even just visually seeing these things and answering those questions, okay? So if you know what we just went over with the PES data, and you know the 7.1 to 7.5 practice problems, you should be fairly ready for Monday's quiz, all right? Which puts us about a day behind. The rest of the stuff we have to cover for this unit, though, it's not difficult, and it's all review, so I think we'll be fine. All right, that's it. See you in class. Hope you had fun wherever you were today.
Just